Hello, everyone.
Hi. Hello.
Hope everyone is doing well. Like some of you might know, as IEEE of the Lebanese University Faculty of Sciences, our goal is to help the students to gain technical skills and soft skills and to help them advance in their career. I want to introduce our committee. I, Maribel El-Kahaf, Chairperson, Gabriela Shibli, Vice Chair, Mary Jane Karam, Secretary, Ora Helu, Treasurer, Elie Dina, Webmaster, and our branch advisor, Dr. Marina Wal Sabra Jmail. Elie Dina will be our speaker for tonight. Elie Dina is a Lebanese university graduate in data science and psychology. He is now undergoing a master's degree in natural language processing at University of Lorraine, France. He worked in different companies in the field of data science, such as UNDP for the project ARS, ARD 2.0, and now working in a debt collection company in Metz, France. Turning his specialization into AI and emotions. Elie Dina, the floor is yours.
Hey everyone, thank you for the presentation, Maribel. I hope you're all doing well. And as you might know already, that today our first meeting is going to be about an introduction to ML, machine learning basically, and how we should proceed with machine learning and data specifically. So I hope that you are able to see my screen. And this session is going to be in English, basically, to take into consideration everyone's background, and especially because it is machine learning and we're talking about computer science and data science. So the international language is going to be in English. If you have any question during the presentation, you can ask them in the chat, and in the end, there will be a section where you will be able to ask your questions directly. So if you're a bit shy to text in the chat, you can already write them down and we can go through it. So basically during the session, we're gonna introduce some basic knowledge, and we're gonna do some lab work in a way where we're gonna work on Google Collaboratory, which is on Google Drive. So I think everyone already has Google Drive. And for you just to know how you should proceed with it and have your own collaboratory on the drive, basically you go to your drive, you go down to more, and if you do not have it already, you click on connect and you search for collaboratory, and here you have it, and then you install it. After clicking here, there will be the install button where you will be able to install it, and you'll have it directly on your drive. So I'm talking about Google Collaboratory, not Jupyter Notebook, not Pip or Anaconda, because it is the easiest way for beginners to work on it, and it has a lot of libraries which you do not have to install. Okay, so let's begin now. We're gonna go through a small introduction about machine learning. What are the different data types? How to get data acquisition, where to save your data. And in the end, we're gonna go through the life cycle of data science, going through exploratory data analysis, which is EDA, pre-processing, and then data visualization. So as we can see here, a little small robot, which is joining us for a small game today. So here you can see that this robot doesn't know what's a cube, and every robot, every machine do not know anything prior teaching them. So he's given a cube, and he doesn't know basically what's a cube. So we inform him that a cube has 6 sides, which make them which are squares. So now he understands. Then he is able to group stuff that are similar together, which is 2 cubes next to another and 2 cylinders next to another. And in the end, we can see that he is trying to classify them based on these small stuff that we have here. So that's already a point of view about it. Okay, just a second. Okay, so what is data? Data is present everywhere. You can find it in your everyday life through text messages, when you're going to the supermarket, when you're eating out with friends. You're handling data on an everyday basis without even knowing it. The message that you're getting on WhatsApp, the meeting that we're having right now, and the recording that's happening, these are all data. We're going to talk about the main data types that you might deal with, which are tabular data, data present in tables, such like Excel, time series, every data that handles time, audios, which are like now at the moment, I'm speaking through an audio, or when some people are sending audio messages one to another, text, which is handling natural language processing. When you're sending a message, an email, these are all texts, images, such like this one or others, and videos, which you know is a series of images, of frames. Regarding now tabular data, so as we can see here, a small data table, sorry, in CSV. We might find different type of data. So we can find integers, which are numbers without any floating point, such like 1, 2, -5, 100. These are all integers. Floats, which are numbers that hold floating points, such like latitude and longitude here. We have 4.7, for example, 120.72, and so on. Strings are specifically for text data. So when we have words or characters, now we talk about handling strings. We also have datetime, which are dates and handled specifically in time series. For example, year, months, day. These are all datetime, especially time UTC, as we can see here in this table. Boolean. What is Boolean? Boolean only holds two values, true or false, 0 or 1. So where false is 0 and 1 is true. And in the end, we might have lists. And lists are basically a summation of different type of data. Or it can be one data or one type of data, or it can be a summation of different types. Which is important to know when we are dealing in a tabular data, each column should have or should handle the same type of data. So in this case, if we have the time UTC, which seems to handle daytime, if in one of these rows there is a word written, like for example, hello, instead of the actual value, then it would transform from daytime into string. Okay? So here's a small example of a code that we're gonna deal with right now. So I took into consideration, just a second for it to load. I took into consideration the Titanic dataset, which I was able to obtain from Kaggle, as we can see here. You can obtain data from different sites, and we're gonna talk about data acquisition later on. But what matters mainly when you're dealing with data is to read the documentation. What does this data contain? Because in some cases, there might be some features, some columns that you are not able to understand. Okay, so for example, here we can see that there are 12 columns. We have passenger ID, survived, P class, name, sex, and so on. And as we can see here, the data that we have are 0 and 1, which might be Boolean, and it might be as well integers. So as we can read, 0 means dead and 1 means alive. So to begin with our first code, in Google Collaboratory, you can have texts like markdowns, where you can add stuff for you to be able to find yourself and understand what's happening. So for example, in that case, I'm gonna write importing libraries to be able to know that in this section, we're gonna be importing specific libraries. And our first library is gonna be pandas. Pandas is a library which help us deal with data frames. And data frames are the tabular data of Python. And usually to import data, import libraries, you use the function import. This as means, if some of you already know SQL, is only to rename the function, the library. So instead of writing every time pandas, whenever we need to call this library, we can only call it by using PD. Now, another text, which will help us to know what we're dealing with, reading and processing the dataset. And do not worry, at the end, we'll be sharing with you the PDF and the codes. So what we should do now is read the data frame that we have, the CSV file that we have in a data frame. And here I call it df. You can call it whatever you want. It is a variable and you can change it basically accordingly. So in our case, we're reading a CSV file. And to be able to read the CSV file, we call the pandas function and use the read CSV function. And in the parentheses, we get the path of the file that you want to work on, and we just copy it. And in that case, we can see that the code is running. And you can see that there is an error, a name error, which is name PD is not defined, which is done because we forgot to run this line of code. So after running it and now running this, we can see that the code is working fine. So every time you might face an issue, you might face an error, just read and you can check them out on Stack Overflow, Geek for Geeks, and you have other documentation where you can find why this error is happening. There is a large community of machine learning engineers and Pythonians as well. So we want to see our data frame, what it looks like. So we just call the data frame df. Usually, you need to use the function print to be able to print stuff. But while dealing in Python, when you call a variable at the end, you'll be able to see it and perceive it without using the function print. So now if I write, like, for example, text equal hello world, we cannot see anymore the data frame because it should be at the end. And now just checked out, we can see now this. So that's the first thing to know. Sometimes we only want to check the first few rows, and sometimes we want to check the last few rows. Okay, so also as well, for us to have comments in our code, you can use the hashtag function, the hashtag character, and write print the data frame. Then if we want to print the few rows that are present above, we use print the first rows. We use df.head, and we open the brackets. And mainly it gives us the first 5 rows. And if we want to change that, we can write how many rows we want. So if we want the first 10 rows, we would write df.head 10. And here we can see that we have the first 10 rows. Same, if you want to check the last few rows, print the last few rows, we would use df.tail, and as well, we can change how many rows we are able to see by using, by entering a number inside the parentheses. So that's the first thing. Now we also want to know how many rows and how many columns we have. We can use df.shape. And it would give us first the number of rows and second the number of columns, and as well for us to write it in a nice text. So for example here, df.shape is a tuple. Every time you see parenthesis in your output, this means it's a tuple. So it can have two variables at the beginning. So as I mentioned first, that the first one is the number of rows and the second one is the number of columns. And do not forget, these are mainly variables. You can change them. You can name them however you want. I'm naming them this way for them to be expressive and for you to know what they mean. So for example, now we want to print how many rows and how many columns we have. I used F so we do not to not have to write n rows and n columns outside the quotes, double quotes. So for example, we can write there are n rows, and columns. And if you want to print that out, so as we can see, there are 418 rows and 12 columns. Furthermore, we want to check what's the name of the columns, how they are named. As well, we can see that the names of the columns are passenger ID, survived, P class, name, sex, age, and so on. And we're gonna continue now with the presentation and then move forward to this. Okay. So here was our first part of the code, as we have seen. Then we can also work on time series data. And time series data works, as I mentioned, on time. As we can see here in this image, we can see how many preprints per month we have during each month of the years evolving from 2014 until 2017. And this graph expresses much because we can see different colors and different shapes for each printing. So here we have, so those are mainly names of articles where we submit articles. So that's it. So time series data, where can we use it? We can use it in finance, in stock analysis, when you want to check if the stock is gonna go up or go down. For weather analysis, how's the weather gonna be tomorrow? Is it gonna be rainy? Is it gonna be cloudy? In engineering, in sensors. As you all know, sensors now are part of our everyday life. And for example, in cars, you now have sensors when you're approaching something and it like goes beep, beep, beep for you to know that you're approaching something. In healthcare, for vital signs as well. Vital signs are the cardiogram that you can see when someone have everything, want to check everything. And energy consumption as well. Now we are talking about audios, and my voice over yours is an audio that you're hearing. It can be used for different stuff. It can be used to store speech, as we're hearing right now, music, as you can hear on Spotify, on Anghami, on YouTube, and symphonies as well. What can we extract from audios? As you have maybe seen back in high school, that every sound have a frequency, an intensity, a pitch. It also has a rhythm and a transcript. The transcript is the textual data that you can be able to extract from the speech. So right now I'm speaking, and if you remember, or if you know, there are some platforms that are able to translate between codes, basically transcript my voice into text. Textual data, which is the field of natural language processing. In NLP, the text consists of characters that we use in everyday life, such like alphabets in any language, whether Latin, Arabic, Chinese, Mandarin, Japanese, and so on. Numbers, which might be floating, integers, and so on. If they're written between codes in Python, they are considered as strings. White spaces as well, and emojis. So when reading the textual data, it is important to take into consideration the encoding that we have, because the text is encoded into the computer. As you might know, computers only understand binary data, 0 and 1s. So they are encoded using ASCII or other encoding algorithms to be able to memorize this data. And by convention, the encoding used is UTF-8. There is also UTF-16 and much more. That's why in some cases when you're texting each other on different platforms, some emojis or some characters are not well perceived because the encoding that you have is not up to date to the encoding of the person who sent the message. Now, dealing with images. Images are part of everyday lives, and an image does say a million words. So as we can see here, the machine will not be, so as we can see here, we have the image, and we are able to see that there is kind of a border to items in it. For example, we can see here there is a pedestrian, store sign, vehicle, the street, the sidewalk, the buildings, and much more. In that case, we need to teach the machine bit by bit, using an image after an image, each one of them, using classification techniques. As you can see, all the trees were considered as other because we did not train the machine to be able to label trees. So everything that is not labeled by them, everything that is not a building, a street sign, a vehicle, a street, a pedestrian, a sidewalk, is considered as other. What's an image? An image is a matrix. It's similar to a matrix. It's similar to a puzzle. It's made of little pixels that are joined one next to another. As we know, we have black and white images, we have gray images, and we have red, green, blue images. The higher the value of the pixel, so pixels are basically numbers, and the higher the number, the higher the intensity. In black and white pictures, the 0 does represent the black and the 1 represent the white. While going from on a gray image, we go from 0 to 255, where 0 represent black, 255 represent white. And in RGB, we have a tuple of 3 different numbers, where each one of them goes from 0 to 255, and each one giving a value to red, green, and blue. So for example, if we have 20, 50, 250, this means that we have 20 for red, 50 for green, and 250 for blue, and so on. Now, video data. Video data is, as you know, a sequence of images going into frames one after the other, following a specific time frame, following specific timestamps. So when we're dealing with video data, we're mainly dealing with time series and actual images. As well, some videos might be accompanied with audios. So in that case, you're also dealing with audio. Data acquisition. Where can you get your data? Because not every data is available, and you always should take into consideration restrictions. So first, you can get your data from a scraping website. So you go into a specific website, you use you might use Excel, Beautiful Soup over Python, and so on, to be able to obtain this specific information that you want or need from this website. But you should take into consideration, is it legal? Do you have the permission to do so? And if so, what are the restrictions? Can you share this data with everyone? Are they private data? Is it ethical to scrape this website? And so on. You should always take into consideration when working with data that you should follow all legal rights and do not share data or do not extract data that might contain some personal information of people. So such like names, bank accounts, addresses, and so on. As well, we have some open source data sets, such like Kaggle, where I was able to get the data that we're gonna work on today. Furthermore, we can also work on surveys, as you have seen or maybe met in your life when you go to the malls or shopping malls. There are some people that might ask you some specific questions if you were satisfied, if you are with or against some specific stuff. So these are surveys as well. In the end, you also have crowdsourcing, which is maybe joining people from the same environment into one place and opening discussions, such like book clubs. So people that like books join together and have discussions about books, different titles. And in that case, the data set will be titles of the books, ratings of it. And if a person reads this type of books, we will be able to store them to, in the end, be able to have a recommendation system for books. Now you've been able to obtain your data. Where should you save it? So saving your data is very, very, very important because it's gonna be lost. You can save them through databases using relational database, non-relational database, hierarchical database. I forgot an A here, sorry. You can also use data warehouse. Data warehouse follow two different data warehouse follow two different functions. So either extract the data from the data warehouse, which is basically a lot bigger than a database. It's a storage room only for data. It extracts the data from there. It transforms them based on your EDA, pre-processing, and so on, and then give it to you. Which,
ممكن ما تعيطش ولا هو؟
sorry? I think, okay. While the extract, load, transform, ELT, extract the data from your data warehouse, load them into your computer, and then transform them accordingly, which gives you the data a lot faster. And then we have data lakes, which has a size between a database and the data warehouse. Now we're gonna move into a data science lifecycle. You get the data, you extract the knowledge, and from this knowledge, you follow an action, you make a decision. Data science and machine learning helps us to get into decision making. What are the steps that you should follow as a data scientist, as a machine learning engineer? First, you need to frame the problem, understand the business that you are working on. What's the topic? What's the issue? Acquire the data that you need. So, for example, in our case, you want to see who were the people that were able to survive the Titanic tragedy. Is it true that, as they say, kids and women first? Are we gonna find at the end that the people that survived the most were women and kids? That's an issue. That's a problem that we might face. You need to acquire the data that you need. So we acquired it from Kaggle, prepare the data. And when we talk about preparing the data, is first you need to pre-process it. And we will see how to do that. Analyze the data using exploratory data analysis, using data visualization, report the findings. So as a data scientist, the projects that you're gonna do are not gonna be for yourself alone. You might do it for fun, for you to be able to get better and better, but in the end, you need to report these findings either to your manager or to your customer. And at the end, you need to act upon analysis. What did you find? How did you analyze this information? What is the knowledge that you were able to get? And then at the end, act upon it. Exploratory data analysis, EDA. It is an essential step in understanding the properties, specifically the statistical properties of the data. For us to be able to do these statistical properties and understand them better, we mainly use data visualization, as we can see here. And it's not only easier for analysis, but it's better to be able to see. When you want to present information to your customer, to your manager, you cannot only give them numbers. You want them to see something beautiful. You want them to see graphs, and that's what helps you. Because even though your work is important, customers do not understand codes. They want stuff that they are able to understand, and not all customers are data scientists. People come from different backgrounds. So as we can see here in this image, you have raw data. You check it out into the exploratory data analysis. To be able to obtain descriptive analysis, you adjust the variable types if needed. We're going to see how to do that. You treat and detect missing variable. You identify what is atypical, what is not usual. You check a correlation of variables, and we're going to see why. And in the end, you'll be able to obtain your conclusions. So as I mentioned before, the goals of EDA are to investigate the data, find the patterns, spotting what is abnormal, what is not correct, and in the end, test your hypothesis. So for example, in our case today, or in the case of the data set that we have, we want to see if female and kids were the ones that survived more than males. So that is our hypothesis that we have. Pre-processing, this is very important. Garbage in, garbage out. If you feed your machine garbage, it's gonna give you more and more garbage. This is why pre-processing the data that you have is a crucial step. As well, it might be frustrating to know, but when you're a machine learning engineer, 80% of your work falls into pre-processing and EDA, while 20% falls into the machine learning part, because we need to remove all the garbage or fix all the garbage that we have. First of all, the first thing that we should do while working on pre-processing is check the shape of your data. That was the first thing that we did on our data frame. Then you should check the different types of the columns. As we have seen before, we have integers, floats, datetime, boolean, strings, and so on. Then you should try to detect null values. These null values might be also named as NAs or NaN, not a number. So you should always be able to detect them. And in the end, check the statistical properties of each columns. So if there are numerical data, you should be able to check the mean, the standard deviation, the quartiles, and so on. And if they're categorical, you should be able to check the frequency of each one of them. You should be able to check the top one, the modes, and so on. So first, let's work on the diagnosis part. If we move back to here, so the first part was to check the shape of your data, which we did using df.shape. Now we want to check the types of the columns that we have. So as we can see first, we have the name of the columns. Now we want to check the types of these columns. And for that, we might use df.info. And as you can see here, this df.info do have 3 different columns. column, which contains the name of the different columns that you have in your data frame. The non-null count, which is basically how many non-null value you have. So you are, as we already seen here before, we have 418 rows. There is someone who is not muted, so if it would be possible to, I'd like to thank you. Okay, so here we can see the number of non-null values, and in that case, we can see that the cabin only have 91, while the age have 332 non-null values, which means that 418 minus 332 are null values. In the end, we can also see the D type, which is the type of the column that you have. So passenger ID is N64, survived is N64, so these are integers. When we fall into objects, mainly these are strings. We are dealing with strings, which is the name of the person and the sex or gender. We also have the age, which is a float number, but as you should know that the age is not a float number, it should be an integer. And you have other columns as well. Then, as we mentioned, after checking the types of the columns, we should detect the null values. Even though this does show the number of non-null values, if you want to check the number of null values, all you have to do is write this code. Just a sec. df.isNull. So this does give you a Boolean dot sum should be able to give you how many null values were there for each column. And when we do run this code, we can see that for passenger ID, we have 0, while for age, we have 86, and cabin, we have 327. So that's the one of the processes that you should go through diagnosis. And in the end, we want to check the statistical properties of each column. And for that, you want to describe this data. And to do so, use the describe function. I know that I might be going fast for some people, or I might be going slow to others. As I said, I'll be sharing this at the end. And there is a lot of, there's a big community out there. You need to find it out. You can check it out, as I mentioned, on Geeks for Geeks, Stack Overflow, and more. So in our case, we can see that we have 418 for mostly everyone except fare and age. So for passenger ID, we are not able to check how many, so for all of those, we are not able to check how many specific unique values we have, but we can see the standard deviation, the mean, the minimum, and so on. In some cases, this isn't good because, for example, in our case here, the passenger ID, it should be unique values. It should be the key. So if you want to check it out, we can use df.passenger ID. That's how it's written. Yep. Dot and unique. And we can see that we have 418 unique values for passenger ID. As well, another way to get into a specific column is using the brackets and write the name of the column. Because in some cases, you do have a space between a word and another. And while using the dot, you are not able to write it out. So in that case, you'll have to use this. So these are the same, but using different nominations. So, for example, for age, for survived, even though it's numbers, it should be Boolean, or it should be Boolean because we have only 0 and 1. For P class, it is we have 3 different classes, which are 1, 2, and 3. And here how we check it out. So for example, if we call P class and use the function value counts, we can see that we have 3 different variables, 3, 1, and 2, where the third class have 218 values, the first class has 107, and the last class have 93 values. Each unique value. So that's it, mainly. Okay. And here we checked the statistical properties for numerical data. What about non-numerical data, categorical data? And for that, statistical. And for that, we use the same function, but in that case, we use the object, include O. Categorical data. And for that, we use df.describe, as we have already mentioned it, include equal big O. And here you'll be able to see that you have the name, the sex, the ticket, the cabin, and embarked. And as we have already mentioned, cabin have a lot of missing values. As we can see here for name, the frequency of the top value is 1, which means that there are 418 unique values as well. For sex, we have 266 males, and the other would be females, and so on. So, and if we want to try it out, so we want to check how many females and males we do have. We use df.sex.value counts as we did before, and we're able to see it out. So 266 males and 152 females. So to continue, so now we did our diagnosis. We were able to check the number of rows, the columns, the names of the columns, the different types that we have, detect the null values, and did a basic statistical property, check the basic statistical properties for each column. Now we want to proceed to cleaning. So first we need to rework on the rows that have non-values. So we either remove these null values, we might remove this column if it contains a lot of null values, we might fill the null values with the median or the mean, and we might be able to inference it. So for example, you might be able to inference the age from the date of birth, and you might be able to inference the year of birth based on the age. It's an approximate estimation because it depends as well from on the months that the person is born on. As well, you can remove unused columns that you will not be able to use, you're not gonna use. Furthermore, you also can remove highly correlated columns. As we mentioned before, some columns might be correlated and we need to check the correlation between them. For example, the date of birth and the age are highly correlated columns, so we remove them. Or as well, if we're back in high school, so if you want to check the grade of someone, in which class they are, and their age, as well, they are gonna be highly correlated, so we can remove one of them. It depends on the work that you want to do and how you want to proceed with it. In the end, you also need to check the duplicates. Do you have any duplicates? And if so, you either remove one of the duplicates or remove the one that has less information. So in some cases, we might have some values that do contain missing information, and it might be duplicated. And the duplicate might contain more information. So we obviously remove the one with less information. So let's go back to the work that we've been doing. So first we said we want to check regarding the null values. And as we have mentioned, we do have 3 columns that do contain null values, which are age, fair, and cabin. So regarding the cabin, it contains 327 null values out of 418. In my opinion, filling it won't be an easy job because you can't fill it with the top, you can't fill it with the median. So in my opinion, it would be better to remove this column. And to proceed with removing a column, unnecessary column, we would work on df.drop. And we open the brackets, columns equal between brackets. And when we write stuff between brackets, this means that we are handling lists. And here we write the name of our class, which in that case, of the column, which in that case was, cabin. And when we check it out, we see that the cabin is not present anymore. But you should pay attention to something. If now we print df, the cabin will appear again. And that is because we did not write. You can handle this in two different ways. Either write df equal df.drop or use the feature in place equal true. And when you mention that in place equal true, this means that df equal df.drop. And now if we print df again, the cabin do not appear anymore. While now for fair, when we're dealing with fair, we only have one missing value. And as we can see here, the fair is a numerical data, having as a maximum for 512, as a minimum 0, and as a mean 35. Now the question is that, should we fill it? Should we remove this row? What should we do? And as we're working on only one data point, on only one row, we might deal with it in different ways. We can say that it's fine, it's only one row, but we're dealing as well with only 418 rows, that this one row might be important. So based on your decision, you can add to it. But as well, you can use the statistical properties to check it out. So you can check if the data is following a normal distribution or if it is skewed. And in the case it is following a normal distribution, it would be better to use the mean value. And based on which skewed it is, skewed to the left or skewed to the right, you can use either the mode or the median. So that is a way to handle it. Furthermore, for age, we have 86 people, 86 passengers that do not have an age. And for that case, we can also fill it based on this information. Is it following a normal distribution and skewed and so on? And based on this kind of stuff, we can deal with that. Then we said removed unused columns, and in our case, the unused column was the fair. No, not the fair, sorry. It was the cabin because it has a lot of NA values. We can check the correlated columns. In our case, we might not have any. And reworking duplicates, remove if we have any duplicate. And to check if you have duplicates, in that case, what you would do. So first, you can check if there is any specific duplicates in the whole data. And here you would write df.duplicated. df.duplicated would give you a Boolean, would give you either true or false. And we are using this df between brackets, df.duplicated, for us to be able to see only the duplicated values, where df.duplicated returns true. And when we run this code, we can see an empty data frame, which means that there is no duplication. But as well, as I've mentioned before, that we might have for two different, we might have rows with the same ID, with the same key, but with one with less information, which would give us non-duplicate. And in that case, we check which is the specific key that we have. And in our case, it is DF, it is passenger ID. And now we check if there is any duplication in passenger ID. And for that, what we should do is DF passenger ID dot duplicated as well dot any. And if there is any duplication for passenger ID, it would give us true. But in our case, we do not have any duplication, so this means it will give us false. Okay. So that's that. Let's continue. Then we need to work on conversion, because in some cases it would be better to transform from categorical to numerical, or from numerical to categorical for handling smaller memory, because the machine requires basically numerical data and so on. So in our case, let's talk about the sex colon. And as you have seen that we have two different variables, which are male and female. And to change these unique values in the colon sex, what we should do is work on that and replace them. So basically we would replace the values male and female by numerical values. And an example of that would be dot replace. We open the parentheses. Now we use the curly brackets, which is mainly a dictionary. And we mentioned that male will be 0 and female would be 1. And this does vary based on what you would prefer. You can change them, you can nominate them however you want. In that case, I wanted male 0 and female 1. You can do the inverse as well. It's correct as well. Okay. So we can see here the values, but you should always remember to mention that, to do this, for it to be for the change to be saved. And now, if we check the data frame for the gender, instead of having female and male, now we do have 0 and 1. And let's check out the information. Before, sex was object, and now it is an integer because it was changed from male to 0 and female to 1. But if we have changed into strings, so if 0 was a string and 1 was a string, what would have happened? And as we can see, it also remained an integer. And why is that? Because the machine was able to see that there is only numerical data, so it was transforming it into numerical data and not strings. If you want them to be specifically numerical data, you need to change it back using as-type str. Okay, so that's that. Let's continue. Then, when dealing with data, data might follow different distributions and different ranges. And as we were able to see in the data frame that we are handling right now, if we go back to this, for example, for survived, it changes between 0 and 1. For P class, it changes between 0.84 and 3. Sorry, not between 1 and 3, sorry. For age, it does change between 0.17, which seems an impossible value. But how can you have a number that is floating for age? So in that case, you should also handle this kind of information, as we mentioned. If you remember in a previous slide, in that slide specifically, identify atypical data. And we were able to identify, in our case in age, we have a floating number, which is not possible. And in that case, you either remove this information or you make a guess that instead of having 0.17, you should have 17. So it's up to you. It's you make your own decision, but in a way, if you are able to have a guess, you can try your guess without removing data. Or if you can make inference based on another column, such like date of birth and so on, try to make it as well. Okay. Let's get back. So we've seen that these ranges do differ. And in some cases, the machine might be biased toward a specific feature because of the different in ranges. So that's why we do use normalization techniques or standardization for them to fall into the same range. So if we do work on normalization, it would fall between 0 and 1, and it would fix all the model's ranges by removing this algorithmic bias toward a specific characteristic or a specific feature. And here's the formula. We take the data point that we are working on. We remove, we do the difference with the minimum value of the data set. Then we divide it by the maximum value minus the minimum value. And that's why it can differ between 0 and 1, because the maximum value would be x max minus x min over x max minus x min, which would give us 1. And it can be x min minus x min, which is basically directly 0. So that's how standardization. Is any person forgot to mute themselves? Thank you. So regarding standardization, it follows the same principle, but in that case, they try to have a mean following 0 equal to 0 and a standard deviation of 1. And here's the formula. We take the value that we are working on. We do the difference with the mean of the feature over the standard deviation. So we would obtain a range between -3 and 3. So that's regarding standardization. Now we're going to talk about data visualization, which is the last part in this workshop today. And mainly when to use each graph, why to use it, and how it might help us in our analysis. So first, line plots. Line plots display information as a series of data points. And as we can see, these are the markers that we have here. And they are connected by a segment, a straight line. Mainly, they are used for continuous data. And as we have seen before, for the time series, we have seen how many preprints we have per month over the years. So that's an example of that. Using the monthly rain for the monthly rainfall, the annual employment versus unemployment rate. In line plots, you can have only one line, such as the graph here, or you can have different ones, as we have seen in the first one in time series. For us to be able to compare these different values. Then we do talk about area plots. Area plots are quite similar to line plots, but the main difference is that we do have as we will see here, we do have some coloration below this line plot. And why do you use this coloration? It is used to be able to communicate the overall trend instead of individual values. So we do face some consequences while dealing with this kind of data. They might be hard to read. Line charts or stack bar charts might be better for readability, and that's normal. But in some cases, we do need to check this out for us to be able to perceive it better and see the difference between them. There are two types of area plots, which are mainly stacked area plot and not stacked area plot. The stacked area plots can help us see a really difference. We read them from the intersection point. So we read, so for example, let's take for 51, we would have 50. But if you want to check for the purple one, we would read the difference between them. So it might be 100 minus 50, and it will give us 50 as well. We do not read it from the beginning. That's a very important point to take into consideration. While for stacked area plots, we do, there are quite, there is transparency in them, and we read them from the x-axis, as we can see in that case. Histograms. Histograms are used to be able to represent the frequency distribution. Is it the guys who is unmuted? So, working on the frequency, we can have normal distribution. We can have skewed data. It can follow binomial distribution, and we can perceive that using the histogram. So that is an important point to take into consideration. As well, it is used for numerical data. So you can't use histograms for categorical data. It is always used for numerical data and mainly continuous ones. When you are working on categorical data, we mainly use the bar charts. We also have two different types. So we have different types. So here is a basic histogram. It can be stacked or it can be overlapped. In our case, we can see here, this is the overlap. And we can see that we are speaking of two durum wheat type, the Ixos and Primadur. And we can see that that the number of plants of Primadur durum wheat is higher than Ixos. So it helps us to this differentiation. In the case where they do happen to be intersecting and not much of a difference happens, we use the stacked histogram. And we can see here the difference. So for example, for age 20, we do have more males than females, and so on. What is important as well is to take into consideration that these graphs, even though are quite readable, to make them even more readable, we should add values upon them. So we can add a value in between or at the top, showing how many actual males and how many actual females we have in each one of them. Now we're gonna talk about the kernel density estimate, which help us visualize the probability density. So as we can see here, we are working on Iris virginica, which is a type of flower. And mainly this type of flower, or basically this data can also be found in Kaggle on which is iris.csv, if I'm not mistaken. And an iris have a sepal and petal, lengths and widths. So here we want to see what's the probability of having the sepal lengths smaller than 6, for example. If you want to check how many sepals have a length less than 6, we would check it out and we would have the probability density of 0.4. So 0.4 of the Iris virginica, or 40% of irises of type virginica, have a sepal length lower than 6. Now, regarding bar charts. Bar charts, as mentioned, do represent for usually categorical variables. It can also be used for numerical ones, but mainly used for categorical ones. There is, as we can see here, a space between the columns, and they are grouped into intervals. So we have the items, and we have how much we have for each of them. So in our case, we do have two types of bar charts: the vertical one, which is here, and the horizontal one, which is that case. Horizontal ones are used to describe the top elements, the ones that we face when we want to check which one are the top ones. So, for example, if you want to check the top sellers or the top rated movies, we would use a horizontal bar chart. While if we are working on trends, time series analysis, and variation in data, we would use typical vertical graphs. Pie charts. Pie charts, as you can see, are circular, and they are called pie because they resemble a pie which we can eat and enjoy. So usually they are used for 6 categories or less, because when we're going over 6 categories, it will be harder to read and it might begin to become quite messy. So it is by convention. It doesn't mean that you cannot use it for more than 6 categories. So as we can see here, each ethnicity had a different color, showing Hispanic was with a 45.4% of the whole data, and so on. What is important as well, when you have percentages and dealing with pie charts, check that the sum of them all is equal to 100% and not more, because it might be a trick that you have in your data while we're giving some actual information that the sum of all percentages is not up to 100. So for example, let's give an example. If you are talking about books, so we have a class or a book club which are reading different types of books, and we say 40% for example, I don't know, fantasy, another 30% like science fiction, a 30% like roman policier, and so on. If you add them up, they would give you a sum more than 100%. And this is normal, because one person can like more than one type of book. The same person can like a roman policier, fantasy book, and science fiction, while someone might not like any of them, while some of them might like two. So this is important to take into consideration. Now, for the box plot, it does represent the 5-number summary, which goes from the minimum, the first quartile, the median, the median, which is the second quartile, the line in yellow, the third quartile, and the maximum. All these points that are above the maximum and below the minimum do represent the outliers, data that do not follow or are not represented correctly in our case. These outliers are usually some specific cases, really rare, and in many cases they are removed. You can remove them, you can take them into consideration. It is up to you. But in many cases they are removed because they do represent a very small community of your data set. That's why they are removed. Okay, now moving on to scatter plots. The scatter plot follow the Cartesian coordinates, the x-axis and the y-axis. And it help us to determine if there is a correlation between features or not. And as we can see in this picture, we do have two different variables, MIP03 and MLS03. And as you can see here, they are following kind of the same line, which is it's showing that they are following a specific trend, meaning that they are highly correlated. Okay? In some cases, the data might be sparse around the graph, which shows that there is no correlation between them. While working on correlation, the value that you might calculate is the Pearson correlation or other type of correlations, and they are represented by R squared or R in that case, and showing that R is 0.99 shows that there is a very high correlation between both features. Furthermore, instead of working on scatter plots, we can also work on bubble plots. And bubble plots are as used as scatter plots, but can go up to 3 to 4 variables. So if you can see here, we first have the points, which we have seen before in the scatter plot, but as well we take into consideration the size of the bubble and the color of the bubble. So for example, let's take into consideration the age, for example, unemployment rate. So for example, here in that case, we have the GDP per capita, the life expectancy. So how does the GDP per capita goes with the life expectancy? So the people that are between 75 and 80 have a GDP capital much higher than the people that lives that have an age less than, or have a life expectancy basically less than 70. If we take into consideration the number, not the number, the population size is the bubble size, and the color might represent either the country or the continent that you are talking about. So this might represent Asia, this color might represent Africa, America, and so on. So these are important. These are also stuff to take into consideration. Then we are working also on subplots. Subplots are mainly different plots, graphs that we put one next to another instead of putting them in the same figure as we have seen before in the overlapped histogram or overlapped area plot. So we put them one next to another for comparison, for easier to perceive them better and faster. Heat maps. Heat maps are mainly are values that are depicted by colors, and they help us to visualize complex data and mainly use to check the correlation between variables. As we can see here in our heat map, we have sepal lengths, sepal widths, petal lengths, and petal widths. And obviously, the sepal lengths will have a correlation of 1 with sepal lengths, sepal widths as well with sepal widths, petal lengths, and petal lengths, and petal widths, and petal widths. If we take into consideration the rest of the values, we can see that we have between petal lengths and petal widths a correlation of 0.963, which means that there is a high correlation between them. So, which means that if we have a big petal, the petal is big, has a big length, it would mean as well that it will have a big width. But if we take into consideration petal lengths and petal widths, sepal widths, we have a correlation of minus 0.428, which means that the bigger the length of the petal, the smaller the length of the sepal, the width of the sepal. But in that case, this correlation is not that high, which means it's not that conclusive. But we were able to see this main idea, or this main correlation, or this main statistical property. While for petal lengths and sepal lengths, they are highly correlated, such as petal widths and sepal lengths. And this might be due, this high correlation between petal lengths and sepal lengths and petal widths and sepal lengths might be due to the high correlation between petal lengths and petal widths. What is important when dealing with data is to be able to analyze the data that you have. And without really analyzing them, you will not be able to go further with the pre-processing and so on. The tree map, it does split the subparts into different rectangles, and it can help us visualize the hierarchical structure of a diagram. It doesn't always show the hierarchy as clearly as other charts, but in some cases, for example, if you take into consideration the big data tree map, you can see which is Hadoop and then the different applications in them. For example, here in that case, we would have that zeta is a parent of eta, and alpha is is one of the descendants of delta and epsilon. So that's a way to read this graph. It depends on how we coded it and why, but this is a way of how to read this. Last but not least, we also have diverging plots. Diverging plots shows us when we have different categories, more than two, and we can see how they are different, changing. So who lies more? A comparison. So some people say that the person has pants on fire, the person does not, mostly lies, or on like, okay, it doesn't lie that much. What he says is half true, what he says is mostly true, and what he says is definitely true. And in our case, we took a minus, negative values for people that lies, and a positive value for people that do not lie. We consider that people here do not lie, and as we can see, that we have a lot of politicians. So as we know, politicians do lie a lot. But in our case, we can see that Trump was considered to always lie, or lie more than speak the truth, as at least. While in that case for Obama, we can see that he mainly speak the truth and lie a bit. And you should take into consideration that not all data is valid. There's always going to be bias into the data, and you should deal with that. You are working on a sample of people. That is a very important point of view to take into consideration. A sample of people does not represent the whole population. It does represent a big part of the population, but not enough to represent the whole population. So this is very important to know how many, what is the size of the sample that you are taking into consideration, and so on. And that's the end. And just to have a bit fun, we are gonna write the code to be able to have a bar chart for sex. So in that case, we want to plot the graph for gender, sex. And as we said, as we are representing categorical variables, we are going to represent, you are going to use a bar chart. So we said that we are going to take sex into consideration. We are going to use value counts to have the number of each, 0 and 1, male and female, sorry. We are going to plot using a bar. So to say that we are working on a bar chart. Then we need to add a label for the x-axis. X label. And for example, in our case, let's say it's sex or gender. PLT dot, wait, this is how we write label. Wait. Then we also need a label for the y-axis. Let's say the frequency, for example. And in the end, we want to have a title, frequency of people based on their gender. And now, as you can see here, there is this kind of mark, and which mentions that PLT is not defined. What is PLT? PLT is another library such as pandas, and it is matplotlib.pyplot. So we use it to be able to represent or to show the graphs that we are working on. Other than matplotlib.pyplot, you can also use Seaborn, and as by convention, it is called SNS. So this is another example of another library used for visualization. And going further with that, we can see this. As I said, you can add the values here for each one of them, and so on. In that case, you have this. If you do not want to see it, what you do is that plt.show, and now it does remove it to only have the actual graph and nothing else. Just a second, because the code is still running. And here it goes. So mainly that was our first part of this session, for you to have a main understanding of how to deal with data, because dealing with data is very important. And if we do not deal with them, we cannot build a good machine to learn from this data. I hope that you enjoyed this session, and if you have any question, please go ask right away. I'm gonna check if we have any questions in the chat. So no. Guys, you can ask anything. Yeah.
Yes, thank you, Elie, for your nice presentation. I need to know, in the tree map concerning the hierarchy, which one is the parent, the lowest one or the highest one?
Usually the parent would be the lowest one, and sons and daughters would be the one that are high above. But it also depends on how you coded them. So people might want to do it in a different way, but mainly the parents are the ones that are down, and we go up in descendants.
Okay, thank you.
Rafael? You can ask your question in the chat, or you can unmute yourself and ask it.
No.
Hi. Are you able to hear me? Okay. I'm not able to hear you, but
I'm talking.
Yeah, okay. Now you're talking.
Okay, so I was asking about the potential of this course. At what point we'll get?
Okay, so mainly on the second part. So as we so this workshop is going to be divided into 4 parts. So this was the first part, which is basically an introduction to machine learning and the data, how to handle them, and so on. On the second session, we are going to differentiate between supervised and unsupervised learning, and we are gonna go deeply, not deeply, but like we are going to handle regression. We are gonna talk about the different regression types, with linear regression, polynomial, and so on. We are gonna have a hands-on working on coding with hyperparameters tuning and so on. Part 3 would handle classification, the different types of machine learnings that do handle classification, such as naive Bayes, SVM, logistic regression, and so on. And we're gonna do a hands-on on one of them. I'm gonna check which classification technique we're gonna work on. And in the end, in part 4, we're gonna check clustering, which is a type of unsupervised learning. So I hope it's
Great. Because I'd appreciate if yeah, sorry, and sorry I disturbed you. I said I would appreciate to get somewhere because I am currently working on a model and I am suffering from a sharp local minimum. I'm having like trouble to get it lower than the lower cost that I'm already having.
What do you mean lower cost?
Are we going to? What I'm trying to say is that I'd appreciate if this course could get to somewhere where we can treat lower sharp minima in order to decrease our cost.
As you mean
Error.
handling time and so on?
Apologies, ما سمعتك.
Handling time. If you want,
No,
I can give you my email. I'm gonna write it down here. And if you have any questions, specific question, you can directly ask them.
okay, great.
So that way, it's better for everyone. Okay, so here I wrote it down. So you can ask me any questions on my email, and usually I do respond during the day.
Thank you a lot.
Welcome. Does anyone else have any other questions, details, specific details? You're welcome, Joseph.
Thank you, Elie.
Anytime. I hope that you enjoyed this session and it was beneficial for most of you, if not all of you.
Thank you, Elie. It was a very nice presentation and fruitful one.
Thank you.
So if you don't have any more questions, I will conclude. Thanks, Elie, for this insightful presentation and clear explanation. Hope that everybody has benefited and took notes. Don't forget to earn the certification. You must attend the 4 sessions of this workshop. Thank you, Elie. يعطيك العافية.
Thank you, Maribel. يعطيك العافية as well. Goodbye, guys.
Bye.